Now let's continue. I needed to stop my video. Now let's continue. Okay, for my body, I'm just going to add a body mover. So I'm coming here and create mono behavior script and call it body mover. And I need another thing. I'm just making a new C# class. Where is the scripting? And empty C# script. And call it all enums. And let's rename this. Okay. And one thing that I did notice is I used E in end of my input manager, and so I should change them. And here as well. And okay, now I have my all enums and my body mover. So let's open them and go to Visual Studio. I don't want this to be a class. I want it to be enum. What is enum? Enum is actually some numbers that is connected to some values. Those values is like a string. But for example, if you want to check, for example, we call someone a hero, we call someone enemy, and if we want to check his enemy or hero by its name, it's not good. So what we need to, it takes time, because checking a string that they are equal together, it needed to check them by character. But in enum, they actually use int value, and you can see, for example, down, right, up, or hero or something like that, and you can use them like that. But it's for your own readability, and it is better for your programming. When you programmed it, you can read it easier. But in the end, it just uses, for example, it just uses as an integer. So let's come here and says I want up, down, and what? Down, and another one right, and left. And I don't want to this enum is called all enums. I like to save all of my enums in one script most of the time, and I'm just going to say direction E or direction enum, or without E. I'm doing this easier. So now let's open our body mover and come here. First, I need my line renderer, because we want to change the value in our line renderer, and call it LR as well as what we did in Line Collider 2D. And I want another. Okay, I want private int position count and private vector tree positions and the positions should be an array. So let's come here and says line renderer is equal to get component, and components what? Get component line renderer. So now we get the line renderer that we have in our game object. And if always add this LR is equal to null, just return. If not, come here and say and do what exactly we did here. we are going to get all of this, and we go body mover here and just uses the global position that we have and global position count. Positions count. Okay, that makes sense. Let's use this. Okay, now, oh no, position count makes more sense. Okay, now I should use this here and everything should be good. But for each position that we have, each both of, no, 2 by 2, they make a segment. A segment is a line with two end of end point, and those points here we call them position. And if you see, we have 4 of them, but we have 3 lines. So for each line, I wanted to have a direct direction that they are going to move after we click. For example, this should go up, left, down. And I'm saying directions, and it should be an array as well. And here I come and say directions is equal to new, new directions, and how many of them? 1 less than our position counts. So if I do this, -1, now everything should be good. Okay, I need another function called private, and I'm just going to call it direction handler, and why it changed everything? Okay, because I didn't say it's void. Direction handler. Okay, now this direction handler should do some stuff. So how do we know our, for example, our line directs to somewhere? Okay, if you see exactly, it doesn't, it's not important if our arrow headed this way or this way, nothing is important. Line, it shows it itself. So if it's the 001 and the next one is -2, it goes up. So if the first y that we have is bigger than the second y that we have, it go upright if the x value is the same. But if the y value is the same and the y is bigger, the second one, the first x is smaller than the second x, then it goes left. So we are going to go here and says if position, and says I -1. Oh, I didn't remember to add one 4. 4 means I is equal to 1, and I less than position count, I plus plus. Why we didn't use I equals 0 like always? Because we are going, if we use I equals 0, we are going to check the 0 value and the next is I plus 1. So we cannot use I is equal, I is less than position count, because we are going to, position count is 4, and when I is 3, we are going to check the position of 3 versus position of 4, and we don't have position of 4. So it's better to do this and check with I -1 vs. Okay, now versus I plus 1. Or you could start from 0 but go to -1 of position count and check with that method. Okay, position I minus 1, if it is equal, that x is equal to position I. Then what happened? Then we come here and say directions of I minus 1 is equal to what? To, this is, we need to use another if for our y-axis, but we can change it in another way. We can say if something like this, but for y, and if this is bigger than this, then, and this is what it makes a GIF, then the value of direction I we have is what? Is up. And if not, this is an if not, is else, so it is direction down. And else, if the x value was not the same, you come here and say this should be here, and you come here and says, okay, this should be x value, and it should be right and left. And you can add another else if, or you can say if this is else if, like this. So if the y value is actually the same, so there's no problem if you manage to not do this and for example change them by accident. So here, and we can add another thing to it. We need to have all of this in this. Okay, now everything should be fine. Okay, if you see, we need at least 2 position count here, so we can come here and says if position count was less than 2, return. These are for safety. Most of the time we do not need them. So okay, and now I want to log this and see if we are true. Log direction I says, okay, direction which I is equal to, this I minus 1 as good. Okay, now let's test this. Okay, now what? Okay, I get it, because none of our body are using this body mover, so I'm just going to add this to it, and let's do for both of them, no, for one of them, so we can test easier, not too many logs. Okay, if you see, the first one is up, second one is left, and the next one is down. It works perfectly. Okay, now we need to move it. To move our body, we are going to use a public method, so we can call it public void, and call it what? Call it body mover, for example. Body mover. Body move. Yes, because this is body mover, yes. Move body. Move body. Okay, now in this move body, there's two parts that we are going to do. First, we need to make the head of our body move with our arrowhead, and the tail should follow. So first part is easier. I'm going to call it another private function that is going to handle this, and call it head mover, move head. And this is the head of our body, not head of our arrow. And we need an float amount, how much we need to move this. An amount should be absolute. Amount is equal to mass f dot absolute and amount. What absolute do? Absolute is just going, if it is -5, for example, it gives you 5. If it is 5, it gives you 5. It always give you positive or 0 if you just give it 0. Okay, now in move body, I'm just going to say move head and pass the amount to it. And now I need to add another private function called move point. It is going to get direction, direction. Okay, let's say first we need to get the amount as well in both of them, and it is void as well. And in move point, you are going to say, and we need to get direction and okay, to say position count, position index, I'm just going to call it int position index, and come back here and get the direction of that index. Or we can do at you can come back here and says if position index is bigger than position count, return. And come here and do a switch. Switch is like multiple if. So when we go if this, for example, direction of, no, I need to pass a direction, I think, because I'm going to change so many things if I do not. So I'm just going to say direction and dir, and says if this dir direction. Okay, so it's like if this direction is equal to this case, for example, this case is direction up, direction up. Do this, and when you finished, break. And the next case, and it goes for itself. Okay, what we need to do is, I wanted to, if direction is up, I'm just going to, for example, if the direction is up, we need to update what? We need to update this, for example, this position, what? Y value, and add it as the amount that we have. So we go here and says positions of position index and dot y is plus to what? Plus equal to the amount that we have. And I need to end this, and this is for our upward. For downward, it is the position minus amount, and down for down, and I can go for right, left. Right is x plus x minus. I think we can check here if we can land. For example, we want to change this to right. If I added this, it should go right. Yeah. So we were right about this. We can back to this and says, okay, now we need to update our positions. And we come here, says lr dot positions, set position, and in set position we can set what position should update. So it says this, and we are going to update that as positions of the position count, the value. Okay, now everything should work, and I'm going to add move point of the direction of 0 and 0 and amount. So yeah, everything should be fine. Direction 0. Okay, direction. What's the name? Okay. And should we check something? Okay, yes, we should check exactly like this. Okay. Now let's test it by just going to add this, for example, move body, and move body of how much? For example, 5. And let's check it. So this body is 0, 0, 0, minus 2, and we can clearly see it added 5 as y value to this line renderer. Okay, now we clearly move our head, but for the tail there is a problem. For the tail, if we just move it for the amount that we have, okay, for example, it goes down, 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 and when it reaches here, if the value amount is bigger than the difference that we had, it should go more. If it is less, it just works as like the head width that we had. If it is equal, we can just delete this. But if it is bigger, we should go more. So now let's come back and come here. It says private float and difference calculator, diff calculator, and what it gets is a direction, a vector 3a, vector 3 dot vector 3a, and another vector 3 b. Okay, so what this difference calculator do? First, we need to use another switch type, so it being more clearer. So we go return, and there is another switch type. For example, we can go direction and switch, and if I open this and end this, now you see there is no error. So we can go directions, for example, up, and it passes to our return what we wanted right now. And we can go for other as well. So what I wanted to pass is I wanted to say mass f or mass, both of them work, but I like mass f more dot abs a dot y minus b dot y. Okay, now we can do this for all of them: up, down, right, and left. And now now we can clearly see this is true. Okay, for right and left, you should check the x values. And because both of them are using absolute, it's not important if we calculate a dot y minus b dot y or b dot y minus a dot y. And you see there is a problem here, and it says what if it is not this 4 but it is always this 4. So we can go like this, and it says if it was not this 4, for example, return 0. Or if we are completely know that it we are not going to change them, for example, we are not going to come here and add any direction to it, we can just say up, down, right? Or if they were not this 3, for example, do this. But I don't want to do that. So now our diff calculator is ready, and we have our move point, so we can clearly make our move tail private void move tail. And let's do this. Come here, get the float amount, and here, and say if. First we need to calculate the amount. No. Okay, what we need to check first? First, we need to check our last and last and the next position that we have. So these two. And direction is direction of the last one. And we can go directions of position count minus 2 and go, and I call float diff is equal to this, and say positions. What am I missing? Directions, positions. It should be fine. And oh, okay, positions. Didn't we have position? Okay, now another positions. How much? Okay, now let's go last one and the other one. So let's debug this and see if it works fine. .log, and I'm just going to use it normally. So the other log that we had was log. I'm just going to comment this and add move tail to our body. So now let's check it. Okay, now we know our difference checker are working fine because the last two difference was 3. For example, we can change that and go to 2 and it should get us 4. And now it gives us 4. Let's try for other position. For example, I'm going to be -2 and for example 4. Let's check the difference. It should be 2 and this is 2. So let's go back to what it was. Okay, now we can go here and use that as our power and says if diff is if the amount that we are going to change is bigger than our difference, we do what? We do positions lr dot position count is equal to minus position count, and I want to check everybody every time when we do this. So okay, now here in move head I'm going to check position count should be like this, but not this way, in this way. I'm going to use this and it should be LR1. So we make sure we do not do any weird stuff. And now this is for our if. And what it does is actually come here. For example, how much we want to move this, our body, it was 5. And the difference here is 4. So it should just remove it. Yeah. But if it is less, for example, we go here and say else value else and come here and say exactly like the head that we had and go for the directions of the last one, exactly like this. Position count of the last position, it is not equal to -2, it is equal to -1, and the amount. So for example, we want to go for the 3 is less than that, so it should work fine. And if we check, yes, it works fine. Now there's a problem. When it was bigger, it was not equal. It was bigger or equal, I assume. Yeah, it should be bigger and equal. If it was bigger, it still didn't remove some amount that we have ended with. For example, when it was 5 and the difference is 4, we have another 1 point of change that we needed to do, and it should be do in this line. So we can come here and say while do this while what? While our amount didn't finishes, so amount is bigger than 0. Okay, but how we can check that? We can check that easily by if our move tail just passes us the amount that is left. And after this if and else, we come here and return what? Return amount minus what? Minus difference that we had. Now this while works till our amount finishes. So for example, if I go for 5, it should delete this first, then it should change this to 1. Sorry, what? Let's debug this. Return amount to what? Oh, okay. Sorry. Amount should be equal to this. Now it should work. Okay. And now you see it is working. And maybe you have a question. For example, when we are deleting, maybe we delete the whole thing. Why we don't check if our position didn't finish? Because it never finishes. Because how much we are going to remove from the tail, we are going to add to the head. So we never end up with no position at all. We always have at least 2 positions in every cases that we have. So now I can delete this and make this reactive to our head mover and come to head and say another, for example, this, and go body mover and go body mover, and in a start we go if body mover was not null, if body mover was not null, let's do this first. Go var parent is equal to transform dot parent, and if parent wasn't null, then we come here and say parent dot, or okay, if it wasn't null, and go parent dot get component in children. Why in children? Because we are in the parent. The parent does not have body mover, and we were at first in head mover, and head mover was in head object. So we go here and go this body mover is equal to body mover. Body doof. What is body doof? Okay, body mover. Now we can come here and pass this to it. So we go here and say body mover. If body mover is still was not null, maybe it is a still null. So you never know. Was not null, then go body mover dot move body and passes amount, and the amount is this. Because we do not get the direction, because we automatically know the direction, so we only need the amount, and it should be working. Let's test it. Okay, if I just click on this, no, why not? Body mover, let's move body, yeah, dot move body, and okay, let's log the amount. For example, here log amount and check if it passes the amount that we have. No, so it didn't find the body mover. We can add it like here, but I don't like it. Let's check why it didn't add. I said if body mover is equal to null, I'm sorry, then it should do this. So our parent, okay, no, So let's just spin all, for example, here and check if it works. Yes, it works. But now I can add it for safety and override it on both of them and do this. Yeah, it works fine. Just delete these, and go for log that you have. Log of element. Okay, now let's check. Everything works fine. Okay, in the next episode, we are going to make this arrow to move backward when this arrow, for example, hit this one, because we want, for example, if this arrow is here and this one is here, they shouldn't pass each other. Okay, I wanted to change this main camera as well. Did I change something that I didn't remember? Yeah, I should change this. Where is it? Line, head, body, input manager, and yeah, they should be the same name. Okay. I wanted to when you just click to, for example, main camera should be out. So click on these. You see? Okay, for example, you can say, what if we give them, for example, rigid body? I don't know, let's try it, but I don't think it works properly. But let's do this, for example, gravity static, for example, I don't know. And the main camera, let's just set this to, for example, 25. No, 15. Yeah, 15 is good. No. Okay, maybe dynamic, but no gravity. Okay, yeah, but at least it detects the I don't know what you can call it. It detects the collision, at least. Okay, but we need to, if the player click on the wrong arrow, the arrow that the path is not clear, it should come back. So in the next episode we are going to do that, and thank you for watching.